Okay, so we're going to look at example 2. So we have the function f of t is equal to negative 7.5 times the value of t plus 60 represents the amount of water in gallons remaining in a tub after t minutes. So what I'm going to do is I'm going to use my calculator. So I'm going to go to y equals, and I've typed in this function. Remember, if you have a different variable, you're always going to use x. And so now I'm going to hit graph, and I can see that I need to adjust my window. Since I know my x values are talking about time and minutes, I'm going to cut off or crop some of these negative x values. And since we're talking about gallons of water, we obviously don't need any negative y's. So I'm going to adjust that. So I'm going to leave maybe 1 or 2 negative x's. I'm going to go out to 10 and just see if that's okay for now. For my y's, I'm going to leave it as negative 10, just so I have a little bit of room under my x-axis showing. And then my y-intercept is 60, so I know I need to go over 60. So I'm going to just try 100, but I'm not going to count by ones. I'm going to count by tens. And then I'm going to hit graph, and I'm going to see if that graph looks okay. And if I decide I need to crop some more off, I certainly can. But notice on your paper, they're only using that first quadrant, so they're only using this part of the graph, which I can see. So now I'm going to go to my table, and I'm going to actually pull off only whole number ordered pairs. So my table will start at 0, 60, there's my y-intercept, 2, 45, so that's why I'm halfway between 40 and 50, and then 4, 30, 6, 15, and then if I go down to 8, that puts me at 0. And then for it to be a graph, we're going to stop right there. Actually not going to draw that part underneath there because in our problem we only go from 60 and then it goes down to 0. I'm not going to extend my graph out because I'm not going to have 0 gallons of water into the negative minutes as well. That's why we don't have this side of the graph, because that would be negative minutes. So now I'm going to use my calculator and I'm going to find this information. So if I want to find my y-intercept, I could look at my equation, or I could go to my calculator, second trace 1, and when x is 0, that's going to give me my y-intercept. I'm going to go second trace 2 to find my x-intercept, so I've got to move my cursor all the way down to where my x-intercept is. So I'm just going to hold it down and let it move across my line. And I want to get as close to where I think the x-intercept is. So there, I'm going to go left twice, enter, right 4 times, enter, and then I'm going to hit enter to guess, and my x-intercept is at 8, 0. That is also my 0, x equals 8. Okay, because those are the same thing. And then my slope is going to be my rise over my run. Now, if I wanted to, I'm just going to look where x is. In my equation, x marks the slope, so my slope is negative 7.5. Okay. So the meaning, well, at 8, 0, that means at 8 minutes, there are 0 gallons of water in the tub. Okay, y-intercept, so the tub has 60 gallons of water to start with. You could say initially the tub has 60 gallons of water. The slope is telling me that the tub loses or decreases, the tub loses. Now I want to change that 7.5 to a fraction because it's going to help me come up with my word. So I'm going to type in 7.5. I already took care of the negative sign by saying loses, coming up with a word that's telling me that I'm going down. So I'm going to math, fraction, and 15. So I'm losing 15 gallons of water every 2 minutes. So every time I go down 15, I've had to go over 2 minutes. Down 15, over 2 minutes. Down 15, I went over 2 minutes to get to the next good point. So that's what your slope is telling you. It's telling you how much you have to go up or down and over horizontally between your good points, or to get from one point to the next.